So like I said in the previous question, determining the direction between force and displacement vector becomes very critical in solving the questions based on work energy theorem. Now let us have a quick view of the question here. To maintain a speed of 80 km per hour by a bus of mass 500 kilogram on a plane rough for 4 kilometer, the work done by the engine of the bus will be. See, some of you were asking me for a generalized flowchart in every chapter. See, actually, such a thing doesn't exist. It comes by practice. It comes by practice that you read a question, you try to understand what it is, and then the flowchart comes to you, on your own. However, if I were to make a basic structure of the questions to do here, it would go like this: visualize the given situation like this. Visualize it. Draw the force, the displacement, and then find out the theta, the angle between them. If it is required, resolve this f into fx and fy, s into sx and sy also, maybe. If you don't, then calculate work done using fs cos theta. Okay? Things will become more clear to you when you complete the solution. So we have a mass of 500 kilogram. Now engine is doing a force which is pushing it towards the right. I'll assume that the bus is moving towards the right. Now this is F engine, force done by the engine, which is causing the relative motion. Now what is the role of friction? The role of friction is to oppose the relative motion. So if F engine is acting towards the right, friction would act towards the left. So the next question comes up: what kind of friction is that? Is static or kinetic? No doubt about it, this has to be kinetic friction. Why? Because the bodies are in relative motion for a long distance, for 4 kilometers. It has to be kinetic friction. Now, moving on to work energy theorem. Let me make a note of that as well. So we have work energy theorem. Now, what does work energy theorem says? Work energy theorem says that the sum of all the forces acting in a system, sum of all the forces acting on a body is equal to the change in kinetic energy of the body. One more time, sum of all the forces acting on a body is equal to the change in kinetic energy of the body. So when we have sum of all the forces acting on the body, first we need to identify what are the various forces acting on it. So one thing that stays common to every question, it goes without saying that we neglect the air resistance. Air resistance, because that is what we call as drag, and that will complicate the equations. So we're not going to calculate. We ignore the drag. Okay, which means there are only two forces acting on it. Well, actually there are four forces. Weight of the body, right, and the normal reaction. So okay, maybe let's explain this thing one time to you. So work done by all forces is equal to change in kinetic energy of the bus, right? So what I'll do is I'll just find out the work done by all forces. So what is work done by all forces? It is work done by the first force. Let us go from this. Okay, let us go from this. F kinetic 1, 2, 3, 4. Okay, so we have work done by the kinetic friction, right, plus work done by the normal reaction, plus work done by weight, plus work done by the engine. Okay, and now we'll find out the direction and force in every case. Case number 1, work done by the kinetic friction. What would that be equal to? It will be equal to force of kinetic friction into displacement of the body into cos theta, right? Similarly, what will be the case for, let me use a different color. What will be the case for normal reaction? It will be normal reaction into displacement of the body into cos theta, right? Another color for mg would be the weight mg, right, into displacement is cos theta plus, now maybe use the engine. So force done by the engine dot s dot, sorry, f dot s, it shouldn't be dot, it should be okay, my bad, it is f dot s in the first step, really expand it to the next step. Okay, f dot s. Now what is this equal to? This is equal to force of kinetic friction into displacement times cos theta plus, what is this? Magnitude, normal reaction, displacement magnitude into cos theta. Now what is this equal to? Mg into s into cos theta. And what is this later equal to? This is force of the engine into s into cos theta. Right, so this is what we have. Now if you try to understand every diagram here, maybe I'll just make use of this diagram here. Okay, and yes, okay, and let us try to understand every concept in detail. All right, sorry for delay. So I've just added a couple of more diagrams here to make sure that you understand the concepts well. So let us first see what is cos theta in here. See, this I can write this as fk into s into, what is cos theta here? What is the net displacement? What is the direction of displacement? Direction of displacement here is towards the right, irrespective of which diagram, which force we are considering, the displacement is always towards the right. Displacement is always towards the right. And which direction is kinetic friction acting in? Kinetic friction is acting in the opposite direction. Which means in this case, what is the value of theta is equal to? Theta here is equal to 180 degrees. You may have a doubt here. Things will become very clear to you once you go through all these explanation. Okay. So this I can write it as into -1 plus normal reaction magnitude into displacement into cos theta. So we have normal reaction which is acting away from the point of contact, like this, away from the point of contact, right? And what is the direction of displacement? Direction of displacement is like this, and therefore what is the magnitude between them? It is theta is equal to 90 degrees. So what is cos 90? This becomes cos 90 becomes 0. Therefore we can say that essentially this term will get eliminated, right? Okay, one more point. What is the direction of let us say weight? So weight is acting downwards, right? Displacement is towards the right, and what is the angle between them? You can translocate this vector, keep it over here. What is the angle between them? The angle between them is 90 degree, which means mg into s into this becomes mg into s into cos 90. What is cos 90? It is 0, and therefore this term also gets eliminated, right? Now the only force here what we left is F engine into S into cos theta. That I can write it over here, plus force engine into S into cos theta. Now what is the direction of displacement here? Towards the right. What is the direction of force given by the engine? Engine is also acting in the same direction. Therefore, what is the angle between them? The angle between them here is 0 degree. Therefore, this can be replaced by, instead of cos theta, we can write here cos 0, which is 1, right? Which is 1. So, therefore, work done by all forces summarizes to work done by friction into -1 plus force done by engine into cos 0, which is 1. Or maybe I can write it even more specific, right? So we have work done by all forces is equal to Fs into K minus Fs into K plus F engine into S. Okay. Let us now come back to the question. So we have work done by all forces is equal to F dot S plus F dot S, which is equal to half mv, which is equal to half mv final square minus half mv initial square. Now what is work done? It is not a vector, it's a scalar. And what is a scalar? A scalar vector is equal to product of two vectors. Now what is F dot X? F dot S? Okay, how did that come? Because vector A dot vector B is equal to magnitude of A into magnitude of B into cos theta. In which case, what is F dot S is equal to F into S into cos theta. F into S into cos theta. What is cos theta is equal to? Here, in the case of friction, it is cos 180, and in case of the work done by engine, it is cos 0. Why? We had a very detailed explanation for the same, and therefore we can write that cos 180, which can be replaced by minus 1, and cos 0 can be replaced by 1, right? So since it is 1, I'll just write it as work done by engine, okay, because that's what we want to find out. So I'll just highlight it as work done by engine. We don't have the value of force required. We don't have the value of force, the force which is done by the force which is exerted by the engine. So we just write it down, work done by the engine. So we have Fk into F into minus 1. Now what is Fk into F? It is minus 4 Fk. So we can transport to the RHS. So that becomes, since it is transposed, we'll have one minus here. So minus here, minus and minus becomes plus, right? Minus into minus will now become plus. Therefore we have Fk is equal to, sorry, work done by engine is equal to minus into minus plus Fk into 4 kilometer, which is the displacement, which is S, into minus 1, right? Okay. Now, what is Fk? It is mu k into n. What is mu k? Given to us as 0.4 into, what is n? N is m into g. Let me write it over here. What is n? N is equal to mg. So this becomes n is equal to mg, which is 500 into 10, 4000. So I'll just transpose. I'll write 500 as 5 into 100. So 0.04 into 100 becomes 4. 5 into 10 becomes 50. Into 4 becomes 20. Into 20, sorry, that becomes 2 lakhs. So you can write this as 4 into 2, which is 8, followed by 2 plus 3, 5 zeros. And I'll write it as 800 into 1000 joules. What is 1000 joules? 1 kilojoules. So we have work done by engine is equal to 800 kilojoules.